you take a look at number 1, I'm showing you what the decoding might look like. 3 less than 6 times a number is 21. And I'm showing you that I bolded 3 less. Less, ladies and gentlemen, most often comes last. That's crazy important. You hear me say that all year long. Less most often comes last. Hey, everybody, you're going to unmute, and I'm going to say that again, and you're going to finish with the word last. Ladies and gentlemen, less most often comes... Yeah, thank you very much. Less most often comes last. It's not always the case because depending upon the phrasing around the word less, it could indicate an inequality or it could indicate that what's coming is being subtracted, but most often less will come last. 3 less than 6 times a number. We don't know the number. 6 times the number is obviously the multiplication of 6. When we don't know a number, we typically call it x in this country. Most other countries call it n, which seems so smart to me because you're looking for a number, so why wouldn't you call it n? But here in America, we call it x. Is most often means equal, tiny word with a big meaning, 21. So hopefully you're taking some notes, you're decoding, you're underline, circling, starring, and that you're recognizing. The big trick in this, honestly, was me helping you with some of the word phrasing I use and getting you to understand that less most often comes last. That's a big mistake. Students often will do 3 minus 6x, which is an inappropriate interpretation. Folks, subtraction is not commutative. 5 minus 2 does not equal 2 minus 5. So you must get the order of subtraction correct or you do not have the correct relationship. All right, assuming we got that correct, hey, here it is. Tooch did it for us. What a nice guy. You're welcome, everybody. You can put up a fence. My hope is that you would undo order of operations. You'd begin by undoing addition and subtraction first. That would require you to add 3 to both expressions to determine the value of x. That would leave us at 6x is equals 24. We would divide out the coefficient of 6, and the result would be 6 is equal to 4. You can check your work real quick. You don't have to do a formal check. You can just do 6 times 4 less 3, equals 21. You can type it in your calculator if you have it available. That's too easy. 24 less 3 is 21. Evaluate each expression if necessary. In this case, we only need to evaluate the expression on the left. And because the 2 expressions are equivalent, we got it right. When you take a look at the second one, ladies and gentlemen, 11 more than twice the number is 17. This actually should have been the first one because this is like crazy easy. More is indicating addition, twice the number, 2 times what we don't know. We'll call that n or x. Is small word with a big meaning equals 17. We're putting up a fence. 11 more than twice the number is 17. Well, if I got rid of the 11 more part, I could probably figure out what the twice the number piece is. You could either subtract it or add the opposite. Subtraction is the same as adding the opposite, and we're left with 2x equals 6. Well, that's a lot easier to consider. 11 more than twice the number 17. Take away the 11, then I just really need to know that twice the number 6. Hey, twice what number is 6? The children all said 3. Tooch, in my old school, Adam, this is where you chime in. You say, Adam chimes in, he says, in my old school, Locust Valley, which is a fantastic district, by the way, we did this in 2nd grade. You didn't do it in 2nd grade, but you might have done it in like 5th or 6th, especially if you were in advanced programming. By the way, you all should be in advanced programming. If Common Core was done the way it was supposed to, if people believed in it, you'd all be in advanced programming. Your generation is 1,000 times smarter than mine ever was. And you have to be, because the problems of the world around you are a lot more complex than ours ever were. So you better be smart if you plan on solving the issues of the world around you. There's some big things going on, and it's up to you guys to figure it out. Old people like me, I'm just getting bald. Hey, my favorite part of virtual learning, you don't see my bald spot. I think every class should be virtual. And then I could go on to believe that the universe doesn't hate me. Ladies and gentlemen, Tom's age doubled and increased by 5 is less than 29. What is the oldest age Tom could be? So this is a great little question. It's a great little tricky 6th grade question, maybe an average 7th grade question, but certainly pretty easy for you all. So we're going to double Tom's age. That means we're going to multiply it by 2. Increased is indicating addition. 5 is less than. So here's where less doesn't always come last, and it's indicating a inequality relationship. When we couple is the small word with big meaning equals with the phrasing less than, we have an equivalency relationship. And that equivalency relationship is describing us the inequality. So he could be many different ages so long as it fits this relationship. We solve it just like a 2-step equation, put up a fence. We undo order of operations, which requires us to subtract 5 from both expressions. We find out that twice his age is less than 24. We divide out the 2, and it turns out that twice his age is less than 12. Ladies and gentlemen, what's the oldest age Tom could be? No, Logan, you just said what I said. Oh, Adam, all that Locust Valley training got you nowhere. No, Mohammed, stop repeating the same answer over and over again. You're making me feel stupid. Thank you, Logan. Yeah, whatever that age is, that's like in the millions. That's way too old, but I think what you're trying to say is 11. Yeah, so if his age is, if you double his age and increase it by 5, he would still remain less than 29. Therefore, the oldest integer possibly age he could be would be 11. Tom could be 11. Sorry, I'm writing on a stylus. That's not my best penmanship, but it's pretty good considering what I'm working with. Yeah, he cannot be 12 because he is less than 12. Now, you could argue that it doesn't say what is the oldest integer age. Well, it does say in years, sorry. So it'd have to be 11 years. That's the indication that we need an integer. If it didn't say what is the oldest Tom could be, you could argue that he could be 11. And I guess, would you do it in a decimal? Or would you have to say like days? 11 years, 364 days old. I don't know what percent that is. So 364 out of 365, if you really wanted to get nerdy. 364 divided by 365. You could say that he is 11.997260274 years old. And then your friends would want to punch you in the face for being such a dork. Okay, 4 times Sam's height minus 15 is greater than 240 inches. That's weird. That's clearly wrong. It should be 55 inches. 240 inches. He's 20 feet tall. Sam's a giant. What is Sam's minimum height in inches? Please change the 240 to 55 if you're working off the worksheet. If you're copying it down, make sure it's 55 inches. And top. Take a minute. I'm not going to click back to Fantastic Voyage. So, to save time, I will just sing it for you. Come on and ride on a fantastic slide, slippity slide. That doesn't distract you, does it? That's like helping. Ladies and gentlemen, my help is that you're solving two-step inequality. I hope that you are following the steps for solving two-step relationships appropriately, because almost every equation, no matter how complex they get, comes down to 2 steps. So if you can do this, you can do the last final steps of most of the work we'll do all year long. I hope that you're choosing to go backwards through order of operations to reverse engineer the problem, because if you learn it that way, then much of what you do for the next 5 to 7 years of your mathematical experience will coordinate with what you're learning now. A lot of teachers try and teach you to memorize stuff. Lowest form of intelligence. Don't memorize things. It makes you dumb. Some things you can memorize, not all things. And h is greater than. Is it 17.5? That's what I'm seeing in the chat. So we're going to add 15 to both expressions. That is going to take care of the 4 times his height decreased by 15 portion of it. And it's going to let us know that 4 times his height should be greater than 70. And if we divide both expressions by 70, is that right, everybody? Do I have to go to my calculator, or can I get a thumbs up on that? Okay, so what is Sam's minimum height in inches? Sam could be... Yeah, Sam could be 18 inches tall. Sam is a small person. That is not terrible. Sam is 2 years old. That's like 1 foot, 1.5 feet. Sam could be 18 inches according to this relationship. His minimum height, the smallest he could be 19, 20, 25. He could be 48. He could be any inch quantity that's appropriate, but the minimum he could be would be 18. That would satisfy this relationship appropriately. So do you have to pay attention to the details? That's a big part of what we start to learn as we navigate this class. The details matter in a big way. That's where a lot of students struggle, is their minds are all over the place and they're not focused as they could be. Number 5, ladies and gentlemen, 7 more than 4 times a number is 27. Give it a shot. Underline, check the star, important information. See if you can come up with your own relationship and solve.
4x plus 7 equals 27.
Yeah, anybody write that differently? Usually, if we're live, like 12 hands go up and somebody says, I had 7 plus, maybe they use a different variable, 4n equals 27. And the hope here, ladies and gentlemen, is that you recognize that because it said 7 more, you might have decoded that first and said positive 7 4 times the number, 4x or 4n, is small word with big meaning equals 27. Had you chosen to reverse the order of 4x and 7, the variable term and the numerical term, you're simply using the commutative property of addition. And it's important that you recognize that because we will see that a lot as we get into more complex situations moving forward. So that is the additive property, that is a commutative property of addition. To commute means to move or change your position. You can change the position of that amounts being added or multiplied with an expression. You will not change the value of the expression. So hopefully you guys subtracted 7. You decrease the 7 from both expressions. You got 4n equals 20. You divided out the coefficient of 4, and you were left with n equals 5. Hey, who all got it right? Show of hands, unmute, say me.
Me. Me.
5 times a number minus 4 is less than 36. Number 6, please. Less 4 is less than 36. 5 times the number, I like it. You're calling the number A, that's fine. Minus, subtract 4 is less than the inequality symbol 36. Add 4, 5a is less than 40, divide by 5, and 5 is in fact less than 8. Any number less than, what did I just, a is less than 8, a is any number less than 8. Everybody cool with that? Sweet, take a look down below. Yep. Volunteer so that you're not just hearing my voice over and over again.
Okay. Jill is a hostess of Taste of Italy restaurant. $8 an hour is her hourly rate of pay. Plus, she gets an additional shift of $25. How many hours would she have to work to earn $81?
Okay, so this is, I've got to start to update this because like back when I first wrote this question, it was like, oh my God, she's getting $8 an hour. Now she's not even getting minimum wage. Why do they hate her? So if you decode it, thank you, Samia. Just so we don't hear my voice over and over again because that could get annoying. That would make me annoyed. We've got that she's getting $8 an hour. We don't know how many hours she works, and that's what we're trying to determine. It says how many hours would she have to work. When we don't know mathematics, typically we call it X. And any appropriate variable, you might want to call it H for this particular relationship. Sometimes we write a let statement. We'll get more specific into that as we move forward. And we might want to describe the word let in mathematics with those that little colon indicates that we're about to define amounts so that we know what it is we're looking for. So I'm going to say let H equal number of hours worked. We'll talk more about let statements as we move forward. It's just a nice place to introduce to you. And that's going to allow me to set up a relationship where I say she's getting $8 an hour or per hour. That would indicate multiplication, 8 times H. Plus she gets a shift pay of $25, and that used to sound like a lot of money too. It doesn't anymore. If I had to update this, I'd probably say she gets $12 an hour, and I'd probably say she gets a shift pay of $50, and that would be more appropriate for where money is at right now. So $8 an hour plus 25. How long will she have to work to earn $81? We need this to be equal to 81. Earn 81, that's our total. I'm going to say this a lot throughout the year. If you're not sure where to start a relationship and you have it, start with the total. So you could have written this backwards. You could have used the property of equality and said, you could have said 81 is the result of the $25 she gets for her shift pay and an additional $8 for every hour. You would have used what's called the property of equality. When two expressions are equal, you can have them on either side of the equal sign, and it will be equivalent. And you may have used the commutative property of addition to reverse the order of 25, her shift pay, and $8 per hour, her hourly rate. Subtract out her shift pay to determine how much more she wants to earn that evening, or as I might say, add the inverse. We're left with 8H equals, anybody? 61.56? That looks right. Divide out the coefficient of 8. So if she would like to make an additional $56 and she's getting paid $8 an hour, how many $8 hours must she work? Divide by 8. Divide by 8. And we find out that H is equal to 7. And you can check your work. 8 times 7 increased by 25. Does that equal 81? Type this into your calculator. Hopefully your calculator spits out 81. And you know you got it right. And then we should actually write a concluding statement. Jill must work an additional or a total of 8 hours to earn a total of $81. Cool. Flip. So we're not hearing my voice.
Frank went shopping for some clothes at the mall and spent a total of $91. If he purchased 2 shirts at $14 each and 3 pairs of pants, write an equation you can use to help determine the price of pants, and solve the equation in the space provided.
I wish I had a little timer. 3 minutes on the clock. Game says twice 14 increased by 3a should equal 91. So I might have, you're going to hear me say a lot of things over and over again throughout the entire year. So if you had heard me say it in question number 7, you might have applied it here. Folks, if you're not sure where to start in a relationship and you have it, a good place to start is always total. Ladies and gentlemen, if you're not sure where to start in a relationship, mathematical relationship, and you have it, a good place to start is with, and that's when you all say the total. Start with the
Total.
total. Thank you, one person. So you could have had 91 equals, and you could have worked your way backwards using the property of equality, knowing that the two expressions are going to be equivalent. The 2 shirts are $14 a piece. You may have simplified that in your set ahead and just written 28, increased by 38, 3a equals 91. Hopefully you're solving a 2-step relationship here. You're subtracting out the $28 to find out what the pants were on their own. We didn't want to use P there. P for pants, maybe. 3a equals, is that 73? Looks like 73 to me. 3a, sorry.
It's 63.
63. My bad. And then we're going to divide out. Sorry, that's crazy sloppy. Let me clean that up. And I'm going to use P. 3 times the price of the pants is equal to $63. Divide by 3, divide by 3. And each pair of pants must have been 21. And it would be a good idea to write a concluding statement. I'm going to skip that for now. Okay, so here's where we talk about revenue, profit, and expenses. So Mike's landscaping charges a rate of $25 per lawn for mowing. Hey, underline circle star important information. And has a business expense of $210 per week. $25 per lawn, $210 per week. If Mike wants his business to make a profit of at least $500 a week, at minimum, how many lawns must he mow? So a really kind of cool question as we're getting the year started off and starting to do algebraic thinking, because a lot of you all, or at least when I was a kid, many of us was trying to start small businesses to make a little extra money. It seems like a lot of those are happening like online now. So here's what we know. We know that he's making $25 per lawn. We know it's going to cost him $210 per week. So maybe he has a helper that he works with. Maybe he's got to gas up the machines. Maybe there are blades that have to be sharpened and so forth. And he wants to make a profit of at least $500. If this confuses you, the language and what have you, and you're not sure where to start a relationship, good place to start is with, if you have it.
The total.
Everybody?
The total.
Thank you.
The total.
So you might have wanted to begin in this instance. Where did that go? You might have wanted to begin, if you weren't sure where to start this relationship, with $500 a week. Now, you might not be comfortable with the total in the expression on the left-hand side, but that is a good place to start. And $500 a week is going to have some relationship with, he has to pay $210. Those are expenses, so that's money he loses. And he's getting $25 per lawn. That's money he makes. So it looks as though we're going to have $25, and we don't know how many lawns he has to mow. When you don't know mathematics, typically you call it X, less the $210 he has to pay. Now, this is going to represent the money he gets to keep, or his profit. Profit is the result of your earnings less your expenses. So his earnings are $25 a lawn, his expenses are $210, and this is his money. The key is he wants his money to be at least $500. If he wants his money to be at least $500, he would like his money to be that much or
Greater?
greater than, yeah. So the greater than symbol has to open towards the expression describing his money. Had you written it in reverse, had you done 25x decreased by $210, it's going to have some relationship with 500. The inequality symbol would have to open towards his money. There are other ways you could have presented this. You could have said, Tooch, in my mind, does anybody have a presentation there that makes sense to them? Tooch, the way I thought of it was like this. Because there is one other way that I'm like, wow, it's not typical to put it together that way, but a student's not wrong if they did. And one of you all might have said, Tooch, he really has 500, but since that's what he wants to keep and he has to take away his expenses, he really needs to make 500 plus an additional 210 for his expenses. And then that should be greater than or equal to $25 per lawn. It's possible that you could have written it that way. It's a little unusual, but somebody might have thought of it like that. So what would have happened in most of these situations is you would have had to undo the subtracting his expenses. You would have gotten $710 should be greater than or equal to 25 per lawn. You would have to divide $25 per lawn into 710 to see how many times it goes in, or to determine how many lawns he has to mow. And he has to multiply 28.4. 28.4 less than X. Folks, the amount of lawns he must mow, if you read it from the variable to the number, it has to be greater than 28.4 lawns. So the minimum number of lawns he mows, Mike must mow. Yes, thank
29.
you. Thank you, people, and I appreciate the feedback in the chat. Mike must mow 29 lawns to earn at least $500 profit. Everybody cool with that? Sorry about that little crash there. And we're going to skip number 10. We're going to go on to number 11. During the holiday season, he put on weight. He weighed 148 pounds. Yeah, I wish. To get in shape for the summer, he wants to take off weight at a rate of 2.5 pounds per month. If he wants his weight to be less than 134 pounds, how many months will he have to diet for? Yeah, I talk a lot about stuff like that because as an old athlete, I'm always concerned about what my weight is. And my brothers own a bunch of gyms in the area. I'm one of 4 boys, and we all did that sort of stuff. So that's partially what's on my mind. Also, it's partially something we should be managing in our health. Hey, a relationship, please, for Corey.
148 minus 2.5x is less than 134.
I like it. A couple of places you could get tripped up here. Obviously, I may have begun with at some point we want to be comparing to 134. I might have had an indication that I'm going to need a relationship, but I'm not ready for it yet. I might have said that he's starting at 148, and we're taking away the 2.5 pounds per month. So mine might have looked a little bit different, only that I would have used the property of equality to reverse the expressions, but I like what we have. One of the things that's a little bit tricky here is the fact that we're dealing with that minus the variable quantity. So that is where some people may have made a mistake. And then the other part that gets a little bit difficult to consider is that at the end of this, in our final analysis, we're going to have to be comparing his weight, currently 148 and going down, to 134. And he's looking for his weight to be less than 134. So the inequality symbol must be pointing towards the expression describing his weight, not what he wants to be at that point. This would require us, and again, a couple of tricky things here. You're not wrong if when you go to solve this, you add 2.5 x's to both sides. It just gets a little tricky to do when you're using extra steps. The most efficient way to solve it is to subtract out the 148 pounds. And you're left with minus 2.5 pounds per month is less than, I believe that is, my brain is shutting down, negative 14. And if that freaks you out, I can't do it on the virtual calculator. For some reason, it keeps crashing Smart Notebook. So I'm not going to open it up right now. I have to figure out what's going on with that. Ladies and gentlemen, what does the minus 14 represent in the context of the question? You're going to hear that phraseology a lot throughout the years. It shows up all over the final in the context of the question. So based on this, what this question is describing, why are we dealing with a minus 14 right now? Aren't we talking about somebody's weight? Isn't that a little bit odd?
Weight that he's losing.
Okay, so it's representing weight lost. He would like to lose 14 pounds, so the negative sign indicates the amount he wants to go down. Who wants Grace? Awesome, yeah. So now it's a little bit awkward to see that because we're dealing with a negative, and at some point we're talking about how many months. So this might look a little weird to you, but watch what happens. When we divide out the coefficient of a decrease of 2.5 pounds per month, we end up dividing a negative by a negative. And a negative divided by a negative is a?
Positive.
Yes, it is. It's a positive.
Positive.
Hey, I don't want to type. I don't want to type it in my calculator because I don't want to break it. Negative 14 divided by negative 2.5 is 5.6. So we're getting 5 6/10 months. We're getting one single x in the expression on the left. The negative 2.5 is dividing into itself perfectly one time. And please don't mess this up. Because you divide an inequality by a negative, you must
Change the sign
Correct.
of
Correct. We've got to reverse the sign. So Corey is going to need to be dieting for greater than 5.6 months. And if we're talking about how many months precisely, he'd have to diet for. Corey must diet for
6 months.
6 months. Yeah, this is kind of cool because not so much in months, but in weeks. If you ever watch like the UFC Ultimate Fighter or even boxing, all those sports are wrestling. That's what I did. All that stuff is based on weight class. And in order to get yourself into the appropriate fighting shape, often you need to make a weight. You need to be a precise weight or less to fight in that particular bout. And myself included, many of us trained fighters would have to think backwards. If I am 196 pounds now and I want to fight in the 175-pound weight class, what would be an appropriate amount for me to try and lose per week if I had to fight X number of weeks from now? Or how much weight would I have to lose to make that weight? So it's one of those type of situations. Folks, there are so many important things that we covered in this beginning to decode and create relationships out of word problems into mathematical context. This is the foundation for the year. This is one of the most important worksheets we do at this early stage because these problems are going to get more intricate. They're going to have more detail. The mathematical relationships are going to get more complex. You've got to decode. Underline, circle, star, important information, or cube if you remember that from 6th grade. You should read a question at minimum 2 times. One time to get an idea what it's talking about. Some dude's losing weight. Awesome. He's cool. Second time for detail. And then honestly, as many times as you need to extract it out as precisely as possible.